The U.S.S. Water Witch was part of the Union Navy's blockading squadron during the Civil War. She patrolled most frequently at Ossabaw Sound, 15 miles south of Savannah, Georgia. In the early morning of June 3, 1864, the Water Witch was captured by the Confederate Navy in a daring raid. The pilot who led the Confederates to the ship was a black slave named Moses Dallas. He was among 6 Confederates killed during the raid. 6 months later, the Confederates burned and sunk the ship in the Vernon River to avoid her recapture by the Union armies advancing on Savannah. With its sails, wooden side wheels, and steam power, the Water Witch combined elements of both old and new ship technologies. The underwater survey will take place over the area of the Vernon River, stretching from the proposed Truman Parkway Bridge to just south of Vernonburg, a distance of approximately 2 miles. The Georgia Department of Transportation has hired the company Tidewater Atlantic Research to perform the survey. Leading the survey is Dr. Gordon Watts, retired director of the Underwater Archaeology Unit of the North Carolina Division of Archives and History. Dr. Watts has investigated the Civil War shipwrecks of the U.S.S. Monitor and C.S.S. Alabama. Assisting in the survey is Harry Pecorelli, a former student of Dr. Watts at East Carolina University. Harry was a member of the team that found the Confederate submarine H.L. Hunley. Settled by Germans in the 18th century, Vernonburg is located along the section of the river called White Bluff. Harry explains how the survey will be performed.
Now, what you're looking at is this is a NOAA chart of the Vernon River. And what we've built using this survey program, HIPAC, we've built a series of lanes, all 50 feet apart, covering the research area. And this just helps us drive the boat right along each lane and collect the data right along that lane. And then just like mowing the lawn, you move over 50 feet and you come back along the next lane and run it back again. Move over another 50 feet, come back again, run that one. And what that ensures is that we have 100% coverage of the survey area. You don't end up with a big hole that you've missed. You haven't covered it with the magnetometer or the sonar. So what you're looking at here are our line files draped over the top of this chart.
And then how do you know how many 50 feet you need to go over? Is there something on there that tells you?
Well, you can look at the width of the river. We know that we want to run a 50 foot lane spacing, and you can look and say, the distance across this river is 770 something feet wide. We can measure that. So at its widest point, we can say, okay, we're going to need 14 lanes to cover this all the way across completely at a 50-foot interval.
The crew will use a magnetometer, or mag, to scan the river. The mag measures changes in the Earth's magnetic field. Any metal deposits from a shipwreck will show up as markings or signatures on the mag's detection screen. At low tide, portions of the Vernon River can be reduced to depths of only 2 to 3 feet. Because of the low water level, the magnetometer is attached to a life vest to avoid scraping along the bottom of the river.
If we don't have about, I'd say 5 feet of water, we literally cannot operate. We start running the engine in the ground. We can't tow the sonar and get any sort of records. And the mag, we're floating the mag right now because it's so shallow. And we're still getting good records with the mag. And we'll come back and sonar once we get some water in here and are able to see something out anywhere near the extremity of the ranges that we're trying to run.
At the end of the first day, Dr. Watts is somewhat perplexed. After hours of scanning the survey area, there are no significant indications of the Water Witch wreck. The next day, the crew returns, this time with a sonar scanner called the Fish. The Fish emits pulses of sound which are reflected off objects in the river. The search begins at high tide. The deeper water allows both the sonar and the magnetometer to be submerged at the same time. The addition of the sonar adds another layer of information for the team. Dr. Watts decides to return to a spot in the river that registered a slight anomaly during the previous day's survey. Harry watches the sonar screen for unusual features on the river bottom, while Dr. Watts continues to monitor the readings from the mag.
I'm picking up this one, these guys here, and there's a bigger clump down here at the bottom.
Tell you what, let's do, Harry.
Alright?
I'm going to spin around one more time. And this time, let's go looking left, switch to 20,
Okay.
and go looking left, and go to 20 meters,
Okay.
and see what that gets us, just for yucks.
Alright, I got a couple of things on the bottom here again.
We went through all over at that time.
Kind of lumpy things.
Oh, I mean big time. We're still in.
Yeah, that's what I mean. I just went over some of that stuff sticking up.
My suggestion is we come back and look at this. Well, that looks like a pretty good target. If this thing is laying parallel to the shoreline, I'd say that that's an unignorable target. Oh, excuse me, I slipped a cog there.
Dr. Watts phones archaeologist Jim Pomfret at the Department of Transportation's headquarters in Atlanta.
And I think that it's a pretty unignorable target. If we were looking for anything up here that could be the remains of Water Witch, that this would be one that we'd absolutely want to check out.
After picking up strong readings on both the magnetometer and the sonar, the survey team heads back to shore to meet with the DNR's Chris McCabe and Dr. David Crass. The DNR presents a rare copy of an 1865 U.S. Coastal Survey map, which marks the location of the ship.
There you go. Jeez, you know, X marks the spot. That's 1865 survey.
I mean, it is dead on it.
That's fantastic.
Unbelievable.
Well,
this is why I do historical archaeology.
Yeah. Well, I tell you what, it's pretty convincing. I mean, the target's right on top of where they have the wreck marked in this chart.
The next morning, the crew prepares to dive on the potential site. Joining Harry Pecorelli is diver Steve Howard. They will have to be ready, as the strong tides of the river will allow only a small window of opportunity.
But I don't think we're going for pretty this morning. We're going by the biggest mag target right now.
2 heavy weights attached to life jackets will serve as buoys to mark the sites of the most significant signatures from the magnetometer reading.
The layback, yes, on all those have been set to 50 feet.
Stand by.
Stand by! Coming up on it. There's the
Now! Chris, bring your camera.
All right, I'm jumping in.
I'd be sort of surprised if they find much of anything. There are a couple of things that show up on the sonar. One of which is a big half moon shaped something laying on the bottom surface that probably may not have anything whatsoever to do with the wreck. May have been something that fouled the wreck years ago.
Yeah.
You know, a big piece of cable or some sort of piece of PVC, or it could be, you know, wire rope. They were using wire rope at the time. It could be something like that. But they're mainly trying to see if there's anything.
The divers feel around the bottom of the river, searching for any debris that might indicate the remains of a ship.
One of those anomalies. See if you can find anything right down around in this area.
Nothing changing on the bottom.
Dr. Watts hands Harry a simple metal rod to probe through the thick mud at the bottom. "30 minutes of diving, and there are no indications of a shipwreck. The bottom of the river is a layer of mud up to 40 feet deep, and it is likely that any remains of his ship are buried deep beneath the river's bottom."
I think I should have went to school to be a lawyer. I think those little things we saw on the sonar that are sticking up, this might be just trees and junk stuck in the mud.
Yeah.
I didn't find that row of them that we saw on the sonar that stick all up, but I found little like hammocks of just clumped up grass and stuff that's gotten just embedded in the mud. And the mud's so soft and deep that it wouldn't be anything for tree roots. I did find a section of a cut off piling down there buried, just humped on the surface.
After hours of searching with high-tech equipment, the crew resorts to the assembly of 10-foot piping, which will be used to poke through the soft mud.
I think it's 40 feet.
All right. Yeah.
That buoy's just laying on the deck. You can pull that out and do anything you want with it.
Water is pumped through the hollow pole to make it easier to push through the dense mud.
We're on it. I feel that. We're on it.
Dr. Watts strikes something unusual.
That feels good. We're on it right there. That's wood, Harry. Good. That's freaking wood. That's all wood.
All right.
That's all metal right there.
Feels metal. Now you got 4 feet showing above the water, 4 feet of water, so that's 8. So that's 12 feet below the surface right there.
12
Below the mud surface. That's shallower than before.
We're probably bonking on some kind of machinery or something, maybe like that. And unless we get to the side of the hull, you know, the hull could be 5 feet below whatever we're tapping on, or more. But at least we know here we're on something. And there's something, and we've got a pretty good idea how far down it is now.
Well, if it did weigh as much as it said, and this has been that nasty mud even back in the day, it would sink right into that nasty. It kept going till it got to
That's right.
hard sand
Yep.
and support it.
With that probe, we can tell whether we are on metal or rock or wood, and so far we've hit wood and metal. And by metal, I don't mean just a piece of a beer can or a bucket or a 55-gallon drum. You know, when we're probing, we'd have gone right through that. So this is serious metal. Machinery of the type that you might expect with a steamer like this.
You can hear it right now.
Yeah, in fact, tap
I'll bounce
on
this
it. You
probe off
can
here.
hear it over here.
Listen to this.
Can you hear that? That's definitely not wood, not shell, not rock. And it does feel like there's some concretion on it, which makes some sense. You could probably raise the wreck, although perhaps by the time you got down excavating inside the hull, if these guys are going to build a replica, that'd be infinitely cheaper than bringing it up and preserving it. And you may find that the fire was so damaging that the best bet would be to record it very thoroughly in an archaeological sense, maybe recovery of some of the steam machinery, artifacts and so forth associated with it, and use them in museum exhibits here in Savannah, over in Columbus and so forth.